let's look at example 6 and we carry on with the second part of the example. You may have forgotten, but never mind. Let's revise a bit. Example 6. The question says that 1%, if you have a known mean and variance, 1% of the sample mean exceeds 1.5 times n. Now you have already found n. N is 433. Let's look at part 2. Part 2 says, given that at most 1%. Can I have attention, please? Part 1 says 1%. Part 2 says at most 1%. It's basically more or less the same, but now it is at most 1%. Which means the probability is not equals to 0.01. The first statement we write here is the probability of x bar greater than 1.5 is smaller than or equals to 0.1. This is actually why this is. Oh my goodness. Sorry, this thing keep jumping. Because the probability of x bar exceeding 1.5 is at most 1%. At most. At most means smaller than or equal to. Make sense? Yes? So, in part 1, we have already solved the equal inequality. The equal equation. We solved part 1 if it's equal. What if it's an inequality? How do we solve? Almost exactly the same. Almost exactly the same. So, you will still standardize. You will still change to lower bound. That means this, you still have to change this to less than. You have to change x bar. You have to standardize x bar. That means you minus mean divided by variance. So, let's do two things at one go. 1 minus probability z smaller than or equals to 1.5 minus mean divided by square root 20 over n smaller than or equals to 0.0. Actually, we have done it in part 1 already. We have already done it in part 1. It's just I repeat the steps. Okay? We have done it in part 1. Exactly the same. It's just that this time it is an inequality. So, which means probability z smaller or equals to 0.5, we bring the root n up, divide by root 20, is greater than or equals to 0.9. Now I want to focus our attention now to this bell curve. We already know from GC from part 1 that this is this value. If you want this area to be 0.99, you shade now you shade this, you pop this one and then you shade this one. You shade. You want the area to be 0.99. From GC, you inverse norm 0.99. Inverse norm 0.99, you will get 2.3263, which actually part 1 you already found. That means probability z smaller than or equals to 2.3263 is actually 0.9. But you want to solve this, you want to solve greater than. But never mind, let's write this down first. Represent it on the bell curve first. This value is 2.3263. Right? You know that if this value is 2.3263, area is 0. But you want z smaller than specific value, you want areas of this left bound area to be greater than 0.99. So does it make sense that now this value, this one, must be on the right hand side of this? Correct? Correct? Yes, must be right hand side. That means this must be greater than 2.32. Can see or cannot see? Can I repeat one more time? Example. Can the answer is 2.4 good? Because probability Z smaller or equal to 2.4 is greater than 0.99, right? The area bigger than 0.99. So, which means 2.4 is good. That means you want this value to be bigger than or equals to this value. So I'm going to write it down. That means this 0.5 root n divided by root 20 must be greater than or equals to 2.3263. If the question requires inequality, I think you will not get full credit if you give equation and you write equal. You cannot solve the same way as question 1. Alright? You cannot solve the same way as question 1. So in the end, you get an n greater than or equals to 432.9. The question requires us to find the set of values. Means you've got to present this in set notation. Remember? Or forgot? I think you all forgot. Right? Set notation means you have to enclose it in curly bracket. They say n belonging to real. Not real, not just real. You need to, n must be an integer. Right? N must be an integer. Because n is the number of samples. N must be an integer. Such that n is larger than or equals to 433. Because you want n to be larger than 433. Can? All good?